I'd like to talk about a problem that I've noticed in every one of my 10 years teaching junior high math. I've taught at 3 different schools in 3 very different neighborhoods with very different class compositions. And this issue is painfully clear to me every single year. And that is, most junior high students can't solve real math problems. What's also clear is our Department of Education sees it too. Every year we get the results from the Grade 8 Provincial Math Assessment. We talk about it for a few minutes, and then we file it away. It took some time to look more closely at the results from the past few years. To me, this doesn't seem like an opportunity to celebrate that only 55% of our students are meeting the expectations. I'd rather draw attention to the 45% of students who are not meeting expectations. That says to me there's a huge problem that hasn't really been solved yet. I know that if I finished even one term with a 45% failure rate, so it's 13 out of 30 students, 13 out of 30 students failing in one term, I'd have to answer to my parents, my admin, the students themselves. I'd have to make some pretty serious changes, and quickly. So the DOE interprets the data, and they're surprisingly open with what the problem is. This document's taken right from their lessons learned publication that they release along with the assessment results. They say the same thing to all 5 of the strands. They say the conclusion is that students need more exposure to application and analysis problems. So that's great. I knew that for a while. The province knows it. So now what? We've got a fixed curriculum, so we can't change that. We've only got 195 days with the kids. We only see them for an hour a day, as it is just teaching the outcomes and with the indicators in mind, and being mindful to balance your assessment styles, staying aware of the skills that they show up with and that they need for next year. Every math teacher I've spoken to would agree that there's barely enough time to get through all of that, let alone find some time to raise the bar with the higher order problem solving. So how do we make that happen in light of what's already on our plates? We need to use the time we have more efficiently. We can't do that using the current traditional model of class time and homework. So if homework time is spent practicing what was taught that day, students could either be confused or frustrated, trying to figure out what happened during class they didn't understand. They might even think they understand, and they actually spent their homework time practicing and rehearsing something that's wrong. That's even worse. So I suggest we reverse the homework and the class time roles. Home time should be devoted to the pre-learning events, where they watch pre-recorded mini lesson or listen to a podcast, or to ignite the prior knowledge or to explore some new concepts independently. Class time then is used to clear up any misconceptions, confusion, and practice those new skills where the teacher can monitor and fix those problems before they start to become routines. The shift in the function of homework and class time represents a move towards a far more student-centered model. Research suggests that this will result in greater student engagement and increased mathematical thinking beyond the classroom. We know that's what they need more of. So our own DOE says the students need to engage more with application and analysis problems in every strand of math. That's something that really should happen in the classroom under instructor's guidance. So with this flipped model, we should have time to do just that. The flipped model results in more meaningful student-centered learning, leads to more experience with more relevant, high-level problems. That added experience leads to more confidence, more success in the areas where they're struggling the most. This is a big change, requires a bit of extra front-load work, takes some time for students to buy into it as well with the new routines, but in the long run, the payoff in the end, I believe it really is worth it. The paper I've attached to this references a handful of other sources, so if you're interested in looking into that, feel free. Thanks for watching.